So now we are going to find the velocity function. Okay, so you should know how to differentiate, correct? Zafan? Zafan, are you in the class?
Yes.
Yeah, Zafan, can you tell me what is the derivative of negative 20t?
Negative 20.
Okay, good. That is good. Okay, negative 20. Can you continue with the other one?
Wait, yeah.
Plus 80. So what should I do with the power?
Bring it down.
Zafan? I should multiply with the power, correct?
Yes.
Then after that? Zafan? After that, what to do? Zafan, are you here? Okay, Avika, what should I do next?
Can you hear me?
Yeah, I can hear you.
And then
Okay, I
copy
bring,
down 4 plus 2t
good.
to the power of minus 1 over 2.
Can I stop here?
Then multiply it with 2.
Yeah, you are right. You see, that is what we require you to know. Can or not? So now this one and this one cancel. So this will be negative 20 plus 80 divided by, okay, I write it like that so that I can solve. So now, if I want to draw the sign diagram for VT, okay, what should I do? Cindy? If I want to draw the sign diagram of VT, what should I do next? Cindy?
Wait lang.
We should be quite familiar with this, AD. So the next step, what should I do? Cindy, quick. You see, if you don't memorize, that's why in the exam you cannot do. The reason is because you are not familiar with the step. Okay, how about Johan?
Yes.
What should I do? If I want to draw the sign diagram of VT.
Wait,
Do you know you want to make your learning very enjoyable and you can do it, correct? You must make sure immediately you memorize it. You don't wait until tomorrow.
Okay.
Yeah. Some of you have given me the answer. So this is a very common thing. So you have to know. So if I want to draw a sign diagram of any given function, first I must find what is the value of t that will make VT equal to 0. So I have to write down this one first.
Okay.
You see, you fail to do maths is not because you are not clever. Because you don't take an effort to go and memorize. Your mind is more than enough thing. You can memorize a lot of things. All right? So now you start to solve this. So this is equal to 20. You cross multiply. equal to 80. You divide by 20. I can do any way I like. I divide by 20. I divide by 20. Yeah. So I got square root of 4 plus 2t is equal to 4. So 4 plus 2t equal to, you see why I can do it so quickly, because it's become part of me already. It's not that I'm cleverer than you. Okay, so after I got this, what should I do next? What should I do next?
Hold on.
I want to draw sign diagram.
Diagram.
What should I do next? Shivani,
The asymptotes.
why I should find asymptote? Is there asymptote here?
No.
Why I say there's no asymptote? Because our domain T is always greater than 0. So
yeah.
you look at the square root, there's no vertical asymptote here.
Right.
Yeah, correct. You're supposed to find vertical asymptote, but in this case, there isn't any. Okay, so what should I do next?
Find the position.
What do you mean by find a position?
We note down the displacement. I'm not sure actually.
Why jot down the displacement?
It's already there, but like
I want to draw the sign diagram of VT. You are not worried. I'm very worried for you, for your SAT too. I want to draw the sign diagram of VT. What should I do next? After I know that when T equal to 6, VT equal to 0, and there is no vertical asymptote. So what should I do next? Okay, Siti Haja.
Yes, Miss.
What should I do next?
Draw the line.
Draw the line. Okay, I understand what you mean. Draw the line. That is what I mean. What should I do next? Okay, then after that?
Mark the x-intercept. The t equals to 6.
Mark the x-intercept. You see, for her, it's so fluent because she knows the step. Yeah, next.
And then use the graphic calculator to test the sign diagram.
Yeah, use the graphic calculator to test the sign. Correct, you see? So I'm using Y1 or Y2?
Y2.
Yes, because Y2 is a VT. So can you please use a graphic calculator and test the sign?
The left one is positive and the right one is negative.
Yeah. Okay. So I've done this part. So now I'm going to do something extra. Okay. From the sign diagram of VT, what can I say about the motion of the particle? What can how can I interpret? Yeah. Yeah. Jensen, is it? Jensen, can you please interpret this for T between 0 and 6? What can you say about the motion of the particle? The object?
The object is moving to the right.
Yes, thank you. The object is moving to the right. So you see the sign diagram, you must know how to interpret. So for t equal to 6, what can you say about the situation of the object? Jensen, continue. Jensen?
The object stop moving.
Yeah, stop moving. Other than that, what else can you say? What else can you say? What else can you say? Yeah. Instead of say stop moving. Yeah, stop moving, but you only stop for a while, correct? So we can use the word momentary at rest. Okay. Or another word. At t equal to 6, the object, some of you have given me the answer, momentarily at rest. Momentarily at rest. Or another word, you all must have seen the question. So that's why instantaneous rest also can. Some more. Rest also can. Another one is reverse its direction of motion. Or if you want to use layman term, make a U-turn. Am I right? Make a U-turn. Right? You make a U-turn. Okay, then for t more than 6. Okay. Kevin?
Moving to the right.
Huh?
Left.
The object is moving to the right. To the left. You see, I also follow you already. Are you okay? So that is how you interpret. Okay, Anna? Okay, let's go to acceleration. Okay, my VT is equal to -20 plus 80 4 plus 2t to the power of -½ So 80. How to find 80? Okay, can I have Hao Xuan? I have to differentiate again, correct? You are right. So Hao Xuan? Great. You don't
V prime t.
Yeah, I know V prime t. So tell me, what is the answer?
V prime t -20
Why?
because
-20 is a constant. The rate of change of constant is 0, young man.
then change behind one.
So this is 0. Plus.
Okay.
You tell me.
And
And then?
Is it 80 times the?
Okay, you just say. I will write down.
Wait,
80
huh?
times.
Times 1/2.
Why 1/2? This is negative.
Got negative. Negative 1/2.
Why you don't know got negative?
I didn't see until.
Why you didn't see?
Sorry.
Just now this one, did you see? Here? Yeah?
I thought. Okay. Continue.
Okay.
Okay.
This is negative half.
Negative half. Yes.
Okay, yes. Then continue.
And then 4 plus 2t.
That's all.
And power negative half.
Ayo, I tell you.
Negative 1 and negative 3/2.
How Xuan, are you planning to fail?
I'm trying my best already.
You are not trying. Off record.
And then equal.
Hey, How Xuan, not done yet. There's one more step, How Xuan, not done yet. There's one more step. How Xuan, another one more step.
Times t 2.
Derivative of 2t is 2. How Xuan, can you please? If I wait until you finish your SAT, then start to scold you again, correct? It's of no help, okay? So, I simplify. It will become negative 80 divided by 4 plus 2t to the power of 3/2. Okay, so you see the acceleration is always positive. How are we going to prove it? Always negative. How are we going to prove it? Still remember how to prove? If I want to prove velocity is always decreasing, that is the part 6 of this question. Always decreasing. So what should I do? So I will do like that. T greater than 0. So the next term I have to write is 4 plus 2t will also be greater than 0. Correct? So therefore, my AT, which is negative number divided by a positive number, will be less than 0. So therefore, your AT sign diagram, so this is to prove, this is your part 6 of this question. That's how you prove. So that means the velocity is always decreasing and the acceleration is always negative. So this is our acceleration sign diagram. Are you okay? Hello? So velocity always decreasing. Does it mean that speed is also always decreasing?
No.
Thaddeus?
Velocity always decreasing.
Does that mean speed is also always decreasing?
Yes.
Thaddeus?
Need to see the sign diagram. If same sign, then if different sign, then decreasing.
Yes. So you see what you memorize. I cannot judge the speed just based on the acceleration or the velocity. I have to judge the changes of the speed based on both velocity and acceleration. Isn't it? I told you that?
Yeah.
So please, there's a lot of things yesterday I told you and you better master it. So the first step to do well in the exam is you have to master the basic rule. Okay, we are done with part 1. Okay, so this is something extra. This is for part 6. Okay, so part 1 done, part 2. This definitely will come out in your SAT2, one of the question, and it will carry 10 marks. That means 1/4 of the paper. You get me? So you want to learn it properly or don't want, I leave it to you. Don't say I didn't warn you. Okay, so part 2. So what should I do? The question asks for initial position. Azif? Azif?
equal to 0.
What equal to 0?
T.
Okay, so I need initial is telling me T equal to 0. Position?
Equation S.
Yes. So that means I'm looking for the displacement when the time is 0. That is called initial position. So these two make up. Position means the S. Initial means the T equal to 0. So can you please use your graphic calculator and tell me what is it, Sarafina? Go to your Y1. Sarafina.
160.
160. Good. Okay. Sarafina, do you mind help me to interpret this value?
Initially, the object is placed 160 meters to the right of the origin.
Thank you. Initially, the object is 160 meters to the right of the origin or the fixed point. So if I have my motion diagram, it will look some sort like this, correct? This is the origin. This is the 160. The object is here when T equal to 0. Am I right? So everything that you calculate, you must imagine like that. Okay, that is part A. Okay, how about part B? How about part B? Yeah? Kiko, Faraki, how to do part B?
You put 16 in S prime in VT.
Why in VT? Because the
you want to find the object.
No. Okay. No. This is part 2. Part 2 only this. Sorry. My mistake. I overlooked. That is part 3 already. Sorry.
You're asking for 3B?
No. I'm asking for 2. I accident. So part 2 only one part.
Yeah.
Yeah. Sorry for that. Okay. So we go to part 3. Okay. We go to part 3. 3A first. Yeah. Kiko, 3A.
For 3A, you just have,
yeah.
or you just take the VT
Mm.
and
Initial
then
velocity.
you in
Correct.
0 because it's
Yeah.
initial velocity.
Yeah, so because initial means T equal to 0, velocity. So you look for V0. Okay, Kiko, can I have the answer?
20 ms negative 1.
Yeah, 20 ms negative 1 meter per second. Okay, Kiko, can you interpret this?
Is it the initial velocity?
Initially, the object.
The object has a velocity of 20 ms negative 1.
So that is not interpret. That is not interpret. That is just read from here. You have to give me the sense of direction, Kiko.
Is it
Try.
initially the object is moving to the right?
Yes,
with
you are
speed
right.
of 20 ms?
Yes, you are right. That is called interpret. Understand? Huh? Initially, the object is moving to the right with the speed of 20 meter per second. So that is called interpret. So now I know if I draw a car, the front of the car will have to face this direction. All right? Am I right? Okay. Then part B for question 3. What should I do? Okay, I'm going to call another person. Okay, Nicholas.
Yes, miss.
Yes?
Which page is it?
Which page is it?
Don't worry, teacher. I can still follow, but just I forgot. Don't know which question is it because I didn't see the book.
3A. I'm not discussing the question from the textbook, Nicholas.
Yes.
I'm discussing question 2 that you are supposed to download from Times.
Oh.
Mm.
Give me a few minutes. Give me a few seconds.
You give you a few seconds. The velocity of the object when t equal to 16.
Pardon?
I think you better go and download. So I caught you, you see? So you see why I have to call you? Okay, Safwan?
Yes, miss.
Yeah. Part B?
We need to sub the t in the equation VR to 16.
Yeah, so we have to sub 16 into the V because we want to find the velocity when t equal to 16. Okay, so what is your answer, Safwan?
Negative 6.667.
Negative 6.67.
Ah.
Okay, meter per second. Okay, so this is the approximate value. Okay, so if the question asks for exact value, if the question asks for exact value, then we have no choice to sub into the formula, okay? Which is negative 20 plus 80 divided by square root of 4 plus 2 times 16. So you get negative 20 plus 80 divided by 6. Am I right? All right. So you use your scientific calculator and count. You will get, this is 20 over 3. So this is the exact value. Understand? So if the question asks for exact value of the velocity, then you have to put like that, negative, sorry, negative. Are you okay? Okay, So, Safwan, can you interpret this?
At t equal to 16,
Okay. Continue.
The object is moving 6.67 meter per second to the left.
Okay, if you say the object is moving 6.67 meter per second, what is that? Is that the speed or
velocity.
the
The velocity of the object is 6.67 meter per second to the left.
Okay, when you say the velocity is negative 6.67 meter per second. You cannot say the velocity is 6.67 meter per second.
Oh, I see. The speed of the object.
Yeah. So you see how important it when you put it into a layman term for people to understand when you put it in a interpret it. So what I can do is instead of at 16 seconds, I can also use the word after 16 seconds. I can use the word after 16 seconds. The object is moving to the left with the speed of 6.67 meters per second. Are you clear? So that is called interpret. So that means you see the object is moving with the decreasing speed. So it moves like that. Someplace, somewhere here, it turn. Then after that, it moves to the left. So that means I know that the object turn at less than 16 seconds, correct? Okay. So that is how we interpret the value that we have counted. Okay. So now, can I move on? Is there any question? No, huh? Let's go to part 4. Okay, when we talk about part 4, discuss the behavior. Okay, this question I also can change it to, is there a limitation to the velocity? Listen, for this question, instead of say discuss the behavior of the velocity as t approaches infinity, I will ask you, is there a limitation for the velocity of the object? Okay. Is there a limitation? So explain. I will ask you to explain. If you say yes, why? If you say no, why? So the question 4, I can rephrase the question in like that. So as long as you have a question that phrased in this form, that means you are studying the behavior of the function as t approaches infinity. So I will write down as t approaches infinity. Okay, so what is the next one that I must write down? Okay, Gladys. I want to study the behavior of the velocity.
Square root of 4 plus 2t.
Yeah, so I have to know what is 4 plus 2t. Will approach
Infinity.
infinity. So the next one, I will write down my vt, correct?
Yes.
That is negative. Oh, no. The next one is not writing vt yet. What is the next one I must write down? Ready?
80 over the square root 4 plus 2t.
Yes, I must write down this. Will approach
0.
or approach 0. So therefore, my vt, which is equal to negative 20 plus 80 over square root of 4 plus 2t, will approach
Negative 20.
negative 20. So is this an upper limit or the lower limit?
Lower
Here
limit.
is a plus. Yeah, so this is a lower limit. So if this is a lower limit, so how am I going to interpret this value? I know this is the horizontal asymptote. Okay, this is the horizontal asymptote. So how am I going to tell people about the value of VT? So I will start to answer the behavior. Okay, I've studied the behavior. So therefore, I make a conclusion. Therefore, the velocity of the object. Okay, what will your conclusion be? Clady, just continue to try.
Decreases until negative 20.
They say the behavior. So you won't know whether it decreases or increases just based on this. You won't be
Okay.
able to know the velocity of the object until negative 20. That is not right. You won't reach 20. When you say approaches negative 20 means you will not reach negative 20. It will be go very close. The rest of the velocity. So if I try to plot the velocity time graph, correct? This is your negative 20. So your graph will be above here. So what can you say about the velocity? The velocity of the object
It's always
will is always okay, up to you. Okay, yeah, you want to say the other way around also can? Is always?
bigger than negative 20.
Is always, yes. Bigger than negative 20 meter per second. Or I can also use another word, the velocity of the object will not go below negative 20 meter per second. It's the same meaning. You see or not? That is how you discuss the behavior. Are you okay? Okay, let's go to this, the interpretation. You have to end with this. Okay, find the limit, find the time and the position of the object when it reverses direction. Okay, that is part 5. So how am I going to do this part? If in the exam. So what I will do is, I will say from part 1. So I tell the examiner, I've done that in part 1 already. From part 1, Vt equal to 0, t is equal to what? So you don't have to do it again. T is equal to 6. Correct? So that so they want the position. So S6. Okay, can someone give me what is S6?
200.
200 meter. Okay, so if I go back to my motion diagram, this is the origin, this is the T. Okay, this is the 160. That is the starting. So this is the initial position. Okay, this is the stopping position. Okay, so the particle is moving to the right for this period of time. So it moves to the right. Because the sign diagram is positive, then we stop. Then after that, it reverses direction. So you go the other way around. Right? Okay? So you see how I view the whole thing. I keep repeating it so that you know. Okay, then, so part 6. I'm going to ask Thaddeus. Part 6, how to do part 6, Thaddeus?
I draw the both sign diagram for VT and AT.
Okay, so I draw, I follow your instruction. I draw both sign diagram of VT and AT, one on top of the others. Why I have to do that? because I want to compare the sign.
Yeah.
You don't draw it side by side. You can't compare. So you see the way you present your own answer. So this is always negative. Write a few negative signs, it doesn't matter. So now, the 6 make the whole thing into 2 important regions, correct?
Yeah.
Yeah, so what should I do for increasing speed?
T greater than 6.
Yeah, so I choose the region that have the same
Sign.
sign. Yeah, so this region, they have the same sign. Same sign. Right? So therefore, okay, they say find the time when the object speed is increasing. The object speed is increasing for t greater than 6 seconds. Done. So this is a very important fact. Okay, show that the velocity is always decreasing. I told you that is part 7, I show already. Okay, part 8. Find the acceleration when t equal to 6. Okay, acceleration after 6 seconds. Okay, so can I have someone give me the answer? Yeah. I almost call everyone. Avika. Avika, can I have the answer? Huh? Avika?
I'm getting it, miss.
Not sub into ST. You are supposed to sub into AT. Sub into acceleration.
Yes, miss. I accidentally clicked graph and now my calculator
Yeah.
is
What you can do,
calculating that.
you off it. You off it.
Oh.
You off it. You accidentally, when you accidentally press the graph, it take a long time, correct? You don't want, correct? You off your graphic calculator.
Oh, okay.
Okay?
Minus 1.25.
Minus negative 1.25. Negative 1.25 meter per second per second. Okay, can someone interpret this? Who want to try? I didn't teach you how to interpret this. I want to see, how do you interpret acceleration?
Wait, can I say the accelerates at the decreasing rate, or do I have to say decelerate at the decreasing rate?
No. If you say deceleration, that means you don't say the negative sign in it.
Oh, okay. So I can just say decelerates.
You can say decelerate at 1.25 meter per second. Okay, so I still don't understand the meaning of decelerate.
Okay.
You have to remember that acceleration is the rate of change of velocity.
Okay. So velocity is.
So I will say, listen, that is, I can also ask you to interpret. At t equal to 6, the velocity of the object is decreasing by 1.25 meter per second in every second. I can interpret like that. At
Okay.
this time, at different time, you will be different. So we can interpret in that way. That is the meaning of acceleration. Yeah. Okay. So this is just something extra. Okay. So now we go to the last part. Okay. Who want to take the wholesale or last part? Kevin, take the wholesale or last part, part 9. You tell
You
me
need
what to do.
draw a motion diagram
You need to
and
draw
find
motion
the
diagram.
ending position.
Yeah. Okay. So what you need to do is find the total distance traveled in the first 16 seconds. So what does that mean? How do you interpret first 16 seconds? So what is the range of time?
T is less than 0. 0 is
More
more
than
than
0.
T, and then 0 is less than 16.
Okay, so this is the situation. So what is the first question you must ask yourself?
Get the initial position and
Don't get the initial position first. You have to go back to your part A. You have to ask yourself, does the object stop during this period of time?
So we have to find the stopping period first.
Yeah, I don't know. So you have to ask yourself, does the object stop during this period of time?
Okay.
Okay, you ask yourself. So in your mind, then you will say from part A, from part 1. This is all the question you ask yourself. You don't have to show to the examiner. You understand or not? That is how you want to do well in your test. So from part 1, Vt equal to 0 when t equal to 6. So is 6 inside here? 0 to 16, 6 is inside, correct? So I must have 3 important positions. So what are the 3 important positions? So you don't so anxious want to draw the sign diagram first. Want to draw the motion diagram, you have to get everything done first. Yeah. So I must look for S0. So make sure you get everything done first. So what is S0, Kevin?
160.
160. Okay, what is S6?
200.
200. What is S16?
160.
160. Okay, so we have start. Okay, we have stop. We have end. Correct? So now we have all the 3 positions. So we can draw the motion diagram. 160 from here, move to here, 200 to the right. Then after that, make a U-turn, move to here, right? So back to 160. So therefore, the total distance traveled and this case is happened to be the same, forward and backward. So you can just take 200 minus 160 times 2. That is 80. Are you okay? So motion in the straight line is not that difficult. You understand or not? So you just make sure you know everything, you know how to do, you know what you must look for, how much you ask yourself. And you must know how to interpret. Because our SAT2 is talking about application of differentiation. Every number that you calculated, you must interpret. So please practice your exercise 3E. Got it, class? It's not very difficult. To get 10 marks for this question is quite okay. I can't run away much one. I may set question like application like when the displacement is decreasing at the fastest rate or increasing at the fastest rate. That means you look for acceleration equal to 0 because acceleration is s double prime x, so inflection point. So that is how you link. So there are certain things you have to, based on the curve property, and you link to the application of calculus in kinematic. Are you clear? Okay, so I hope I've given you 10 marks for your SAT2. The curve property is about 8 marks, so it's half of the paper. So another 2 questions, we will talk about it next week. One is the rate of change, the other one is optimization. So you want to have your SAT2 next year, or you want to have your SAT2 this year? Hello, class? Next year. Okay, next year. Everyone next year. This year very stressful year, correct? Next year I see you face to face. But next year, make sure during the holiday you do your work, lor. If not, you forget everything.
Well, wait, we have holiday?
Yeah, we have 2 weeks holiday.
Oh.
Or 3 weeks holiday. We have a semester break. Okay, so never mind. Thank you, class.
Thank you, Ms. Bar.
Thank you, Miss.
Thank you, Miss.